Okay. So we will start ray optics and optical instrument. In ray optics, basically we study the rectilinear propagation of light, that light propagate in a straight line. So we will study the propagation of light or the straight line path of the light through different mediums, through different optical instruments like lens, like mirror, like prism. So today we are going to study refraction through a prism. So how the light behave through a prism, that is our topic of discussion today. So let us take a prism. So you can see prism is a triangular shape arrangement with angle of prism A and base of the prism as BC. So this is made up of glass. And let us take a ray of light. So P is a ray of light which meets the prism at point Q. And at point Q, we draw a normal Ln. So this light P is making an angle I with the normal, and this angle is called angle of incidence. So when this is our rarer medium and the prism is a denser medium, and we know that when light propagates from rarer medium to denser medium, then it will bend towards the normal. So actual path, expected path of the light is this. If there is no prism in the path of light, then light should propagate through this path. But because of the presence of prism material, the light, rather than following this path, it will bend and it will trace this path. And finally, the ray of light that enters into the prism at point Q, making an angle R1 with normal, which is called angle of refraction. And then finally, it will hit the other side of the prism and meet at point R, making another angle which is called R2. This is the first refraction and this is the second refraction. Actually, this is the angle of, you can say this is angle of incidence at this place, but this is called refraction. Why it is called refraction? Because if we place a plane mirror over here, then we know that light will retrace its path and it will go back. Then this will become angle of incidence and this will become angle of refraction. So because of the principle of reversibility of light, this angle is called the refraction. And this is the expected path of the ray of light and this is the actual path. If we reproduce back this actual path, then this will meet the expected ray at this point E. An angle subtended by the expected path and the actual path, it is called angle of deviation. So we have angle of deviation delta, angle of incidence I, angle of refraction R1, angle of refraction R2. And this is angle of emergence. So let me write all these angles. What are the names of these angles? So angle I, this is called angle of incidence. Angle of incidence. R1 and R2, they are called angle of refraction. And this E, this is called angle of emergence. Angle of emergence. And this delta, this is called angle of deviation. So this angle of deviation is very important because this is the expected path of the ray of light, expected path and this is the actual path. Actual path. Now we can define the angle of deviation. It is the angle between the expected path and actual path. What is delta? Delta is the angle between the expected path of the light. Expected path was this path and actual path is this path. So this is the angle delta. Okay, so let me go further. Now, in this topic, our target is to make a relation between angle of prism. This is angle of prism A, delta, angle of incidence, angle of refraction R1, and this is angle of refraction R2, and angle of emergence. So basically our target is to make a relation between all these angles, angle of prism, angle of deviation, and all the angle of incidence, angle of refraction. So how we can make a relation between these? So let us go for that. So choose a triangle EQR. This is EQR. Now in this triangle, this delta is called the exterior angle and these are the interior angles. So let me show, this is the interior angle and this is the interior angle. Now how we can find out these interior angles? Very simple, because this is total angle is I. So this complete angle, this should also equal to I. This should equal to I. So we want to find out this angle. So this angle is I minus R1. So this is I minus R1. This small angle. This small angle is I minus R1. I minus R1. Because the complete angle is I. Because this angle is I, so this is vertically opposite angle. This must also equal to I. So we are interested in this small angle. So this will be I minus R1. Likewise, because this angle is E, so this complete angle should equal to E. And we are interested in this small angle. So this is E minus R2, right? E minus R2. Now we can find out delta. Delta is the exterior angle, and we know that the exterior angle, it is equal to sum of the interior angles. So exterior angle delta, it is equal to sum of the interior angles. Interior angle is I minus R1. So I minus R1 plus E minus R2. E minus R2. Now by rearranging, we can find delta is equal to I plus E, they are kept together, and both the angle of refraction, they are kept together. So finally we get delta is equal to I plus E minus R1 plus R2. So this is the angle of deviation between the expected path and the actual path. Now choose the quadrilateral AQNR. AQNR. This is our quadrilateral, and in the quadrilateral we know the sum of the opposite angle is equal to 180 degree. So angle A plus angle QNR, that is equal to 180 degree, because in a quadrilateral the sum of the opposite angle is equal to 180 degree. So this angle A, which is angle of prism, plus this angle QNR. Basically we are interested in this angle. Let me show you. We are interested in this angle. So in the quadrilateral AQNR, the sum of the opposite angles, that is equal to 180 degrees. So angle A plus QNR is equal to 180 degree. Take it equation 1. Now we want to find out this QNR. Now to find out this QNR, take the triangle QNR, and in the triangle we know this angle is R1, this angle is R2, and keep this angle as X and find out this X. Okay, or you try to find out this X. So we can find so R1 plus, or you need not to take this X, just keep it as Q and R. So R1 plus R2 plus Q and R. Again, the sum of the three angles, again that is equal to 180 degree in a triangle. In this triangle Q and R, R1 plus R2 plus Q and R. Now from the equation 2, find out Q and R. So you will find Q and R is equal to 180. So Q and R is equal to 180 minus R1 plus R2, and put the value of Q and R from equation 2 in this equation. So what we will get? We will get angle A plus 180 minus R1 plus R2 is equal to 180. This 180 is cancelled. So angle A is equal to R1 plus R2. So we were interested in this angle A, and we have calculated that angle A. It is the sum of R1 plus R2. This R1 plus R2, right? So note up to here. Now angle A, finally it is equal to R1 plus R2, and take it to equation 3. Now again go back to the equation delta is equal to I minus R1 plus E minus R2, and delta is equal to I plus E R1 plus R2. Now already we know that R1 plus R2 is equal to A. Now place the value of R1 and R2. So final equation we will have, the final equation for the deviation, we will have delta is equal to I plus E minus A. So this is our equation number 4, where delta is called the deviation, I is called the angle of incidence, E is called angle of emergence, and A is called the angle of prism. So this is a very important formula which makes a relation between angle of prism and angle of deviation. Now let us plot a graph between angle of deviation and angle of prism. So you take angle of incidence along the x-axis and angle of deviation along the y-axis. Angle of incidence along the x-axis and angle of deviation along the y-axis. So you will get a graph like this, a U-shaped graph, Now you start from this point, origin, start from origin. So as we increase angle of incidence, so you see that initially the deviation is maximum when angle of incidence is I1, but as we keep on increasing the angle of incidence, the angle of deviation decreases, and finally it becomes delta M, minimum deviation. This is called minimum deviation when angle of incidence become equal to angle of emergence. So for this particular set of angles, when I is equal to E, means if angle of incidence is 45 degree, then angle of emergence is also 45 degree. So whatever angle of incidence the light follow, the same angle of emergence the light will follow. So in that case, the prism will offer minimum deviation. So this is the case, this is a very important case, when the prism offer minimum deviation, the prism will offer minimum deviation only in the case when angle of incidence will become equal to angle of emergence. So this is the point we can show in the graph when angle of incidence is equal to angle of emergence. So at that point, the prism will offer minimum deviation. So starting from here, as we keep on increasing the angle of incidence and we reach up to a point where angle of incidence become equal to angle of emergence, so deviation decreases. But after this point, again, as the angle of incidence increases, deviation also start increasing. You see, after this point, as further we keep on increasing the angle of incidence, then our deviation that start increasing. So what is the conclusion? The conclusion is that initially the angle of incidence is small, but angle of deviation is maximum. But later on, at a point when angle of incidence become equal to angle of emergence, the deviation become minimum. But beyond that, or after that, after I is equal to E, if further we keep on increasing angle of incidence, the deviation that decreases, right? So this is the graph between angle of incidence and deviation through a prism. And this is delta M is very important because in this case, the prism offers minimum deviation. Now, when R1 become equal to, when I become equal to E, in that case, R1 also become equal to R2. When angle of incidence become equal to angle of emergence, in that case, R1 become equal to R2. Now, we can see from our equations, because we have R1 plus R2 is equal to A. So when R1 is equal to R2 is equal to R. So this become R plus R is equal to A. So this become 2R is equal to A, or R is equal to A by 2. So this is R is equal to A by 2. This is our fifth equation. Now, take the case of minimum deviation from equation number 4. Delta M or dm, because I and E they are also equal, so that becomes 2I minus A. So this can be written as from here we can find out I. So I is equal to A plus dm by 2. Angle of incidence is equal to A plus dm by 2. This is our equation number 6. Now we know how to find out the refractive index of the prism. Refractive index, that is equal to sine I upon sine R. Already we know that what is sine I A plus dm by 2 sine R A by 2. So from this formula we can find refractive index of the prism. So refractive index of the prism, that is N21 is equal to N2 upon N1. It is a ratio of angle of sine of the angle of incidence and sine of the angle of refraction. So angle of incidence we know it is A plus dm by 2. Angle of refraction also we know sine A by 2. So we can find out the refractive index of the prism. Now if the prism is thin, then we know that for a thin prism, sine I that is nearly equal to I, and sine R that is also nearly equal to R. So for a thin prism, sine they will be eliminated, only we will use the angles. So this will be the angle, because sine side they become cancelled, and only we are left with angle of incidence and angle of refraction. So this becomes N21. The refractive index of the prism is equal to A plus dm by 2 divided by A by 2. Now by rearranging again by rearranging and cancelling these two from both the sides. So what is left? We are left with N21. Now we can find out this minimum deviation. So minimum deviation that becomes equal to N21 A minus A, and finally we will get delta M is equal to N21 minus 1 A, that will come out. So this is the case of minimum deviation. So if the prism is thin, for a thin prism, angle of prism is very small, so that's why the deviation is also very small. But if we take a thick prism, for a thick prism, the angle of prism that will be large, so deviation that will be large. So now from this formula we can compare we can compare the deviation offered by a thin prism and the deviation offered by a thick prism. So from this formula, we can conclude thin prism that offers very small deviation, or it will the thin prism does not deviate light much. Very small deviation will be there as compared to the thick prism. So that's all for today. ठीक है अंजलि, खुशी, इसकी रिकॉर्डिंग भी भेज रहा हूं मैं.
Thank you, sir.
ओके.